Welcome to Magic, monitoring attraction guest flow with interactive charts. This project was developed for the Seminar in Advanced Software Development by Valencia. Quick introduction, I'm John Sapp. This is my last semester in the Computing Technology and Software Development degree with Valencia College. When's the best time to visit a theme park? Each season brings different weather, different holidays, and different crowd levels. So how do you maximize your time in the parks? This project aims to give some insight. Quick overview. The idea of this project was to create theme park wait time visualizer. To do so, we have to collect data from an API, store that data, and then display that data via some type of intuitive graph. Tech and tools. My project is mostly written with Python. The web application is written with Django and styled with Bootstrap CSS. I use a MySQL database to store and retrieve data. Apache Airflow was used to automate API calls, and Plotly is used with Django to display graphs. The three main steps of my implementation are to collect data, build an application so we can interact with it, and then display that data on the website. Data collection. To collect my data, I automated a Python script using Apache Airflow. The Airflow runs a DAG, or a directed acyclic graph. This triggers the Python script to run once every 10 minutes between 8 a.m. and 10 p.m. The Python script then parses the JSON, turns each row into an object, and then stores that object into a MySQL database. I learned how to use Django to build a full-stack application. Again, it's mostly Python and it's styled with Bootstrap 4. For our graphs, we have a line graph and a bar graph that share the same space. The line represents the wait time versus the time of day, and the bar graph shows whether or not the attraction was open. I found this visualization useful, as we see in this graph here, just after 6 p.m., 1800 hours, the wait time goes to 0. Without the bar graph, we wouldn't know that the ride necessarily had a downtime or that it was closed, thus causing the drop in wait time. Using both of these graphs together paints a better picture of what's happening with that attraction. Let's head on over and do a quick demonstration. Welcome to my Magic app. I plan to build more of this app out later in the future, so we do have some pages here that kind of just only show some placeholder message. So when we first load up the app, we go to the home page, brings us here. We just get a message that says welcome and a little bit about what this app is. Then we get to, let's go ahead and look at heat map. In the future, I would like to add a heat map that's animated throughout the day. This way, when you're looking at it, you can kind of see the hot spots of the park. This might help you plan out the day by avoiding the hot areas. The hot areas would be the attractions with the highest wait time. Let's go ahead and look at our wait time graph. Once on the wait time graph page, the user is presented with our options here. They have to select from one of our theme parks. This is dynamically allocated from the theme parks in our database. So we're going to select Hollywood Studios. When we select Hollywood Studios, this dropdown is updated with just the attractions at Hollywood Studios. We're going to choose Rock and Roller Coaster starring Aerosmith. Let's say Monday the 16th through, let's say, Wednesday the 18th here. We'll click Submit. On the back end, the data is being pulled from the database and the graph is being created. We can see here that our blocks of time are coming in. I did have a little bit of trouble with Apache. It was a little heavy for my computer to run at times and it kind of chugged a little bit. So some data is lost, but we can see here, this looks like a full day of data collection. And we can see that it starts at 8:30 a.m. and ends, our last wait time is at 9. So it looks like after this, although we were still collecting data, all times were 0. So we can go and we can do a few things. Plotly is great. It lets us toggle. We can even come in here and take a closer look at this day. We can see that our wait time peaked at 65 minutes. Yep, 65 minutes is the peak. And then we also have our attraction status bars back here. So the attraction was open from 8:30 a.m. till, that's 3:45 p.m. And then there was a gap of about an hour here where the attraction wasn't open. And then when it reopened, it opened with a 50-minute wait, and it kind of stayed around 50, 60 minutes for the rest of the day before finally closing. The user can, of course, then come back up here, select whatever other attraction they would like on whatever day that they would like, so the user can continually submit for new attractions. All right, moving on. So the findings from our data show that our wait times tend to fluctuate around a daily average, like we see here on our Rock and Roller Coaster. The park itself seems to want to allow about a 45 to a 60-minute wait for that day, Kind of seems that that's what the guests are willing to accept for that day. We can think of this like a supply and demand type thing. Guests don't directly, control the wait times. However, guests can choose to spend their time on other attractions other than waiting for Rock and Roller Coaster. They can go ride Tower of Terror or one of the other attractions at Hollywood Studios, meaning that there is an upper threshold for acceptable wait times for that day. There are also certain attractions here, like we see at the Haunted Mansion, where the wait times tend to decrease as we get later into the day. This could be due to, many factors. At Magic Kingdom, there are nighttime shows. They actually just recently started a new nighttime parade, so it would be interesting in looking at the data over the course of the next few weeks to see if the attractions drop off more steeply at night as people are more willing to go wait for the new parade than they are to go ride one of these classic attractions. However, this data is useful because if you're at the Magic Kingdom and you really want to ride the Haunted Mansion, you may know, hey, towards the end of the night, the Haunted Mansion is usually at a lower wait time. So we'll save that for later in the evening. So a few of the technical challenges. I learned a lot of new technology to make this project. Actually, everything about this project was new technological to me. I had a little bit of experience writing Python with a few other classes that I've had, but I haven't really built out a real program. On top of that, Django and Bootstrap are all brand new to me, along with Apache Airflow. Apache Airflow did give me some actual technical challenges as I was running it locally on my machine. I do live in an area that suffers from power brownouts at just random occasions, mostly during times of weather. So I did have a few instances while collecting data where my computer just completely turned off due to a power failure. So there are some gaps in my data there. If I were to do this again, I would implement this into a cloud solution to high reliable uptimes. So let's look at some of our successes. We successfully collected over 180,000 rows of data despite our technical difficulties with Apache Airflow, and I built a full stack web application using technology that was brand new to me. One of the disappointments is I didn't have time to add more features. I do plan on working on this project to add to my portfolio. I wasn't able to add the animated heat map, and I also had an idea for a busy day indicator that would essentially take the area under the curve of our wait time versus time plots, kind of average that out. And then you could say, hey, this day was busy, this day wasn't busy. Those are all features that can be added later. If I could do this project over again, I would spend a little bit more time with my MySQL schema. As it currently stands, when I make the API calls, the data is turned into objects, which is then put into a database. And that database is just one table. So there is a lot of repeated information, like the park, the land, the attraction name. With a better schema, this might look like having a table just for parks, and then a table for lands in that park, and then for attractions in that land. And then you would have your wait times. I think this would streamline our data queries as it does take a little bit longer than I would like for the information to return. However, I do think my project was successful in gathering data and displaying it through some medium via my website. That's my presentation. Thank you.